Okay, welcome. I call this talk Modern Web Application Bugs, although in the program it said something else. It said also beyond the OWASP Top 10, and I'll get back to that, why I removed it. But a little bit about me first. My name is Erlend Oftedal. I work at a company called Blank. I do all kinds of security-related stuff, development, security testing, and I'm also doing quite a lot of bug bounty hunting. I also build open source security tools such as Retire.js, and I'm head of the OWASP chapter here in Oslo. And there you also have my Twitter handle. So, while doing these bug bounties, I was sort of looking at the OWASP Top 10, and this is the old OWASP Top 10, the one from 2013. And I was looking at it and I thought, well, there's quite a lot of stuff missing here, because I see a lot of these things that pop up in this bug bounty program that's not mentioned. And then when the RC1 of the new OWASP Top 10 came out, I thought, well, these things are still missing, which is odd. It sounds like I have some weird noises coming from my microphone. Sorry about that. And you can see here the blue ones, those were the new suggestions, and the green ones were merged. So we had A4 and A7 were merged into A4, and A10 was gone. And these new ones, they created quite a bit of controversy. And especially the last one, A10, under protected APIs, that sounds a bit odd. But never mind. Like at this time, this was the time where I suggested this talk for this conference. But then, of course, something happened. The new OWASP Top 10 ended up looking like this instead. So they really changed things around, and they moved. Some things have just moved places, but we have a new A4 and a new A8 and a new A10. And unfortunately for me, A4 and A8 were supposed to be in this talk. And now they were in the OWASP Top 10, so it's no longer beyond. But, and I was now thinking, what should I do about this? Because, or I could cheat. I could pick the ones that were removed, and then instead of those that I intended to talk about. But I decided, well, I'm going to go with my original plan, because I think these things are important, and I'm going to go beyond what it says in the OWASP Top 10. I'm going to show you a bit more. And I think it will be useful for you anyway. And not everything here is in the OWASP Top 10 either, because I'm going to show a lot of different things. If we go to these bug bounty programs, they often publish statistics. So this is from BugCrowd from 2017. And we see SQL injection is still one of the most common ones here, which kind of reflects the OWASP Top 10. The 63% for the long one, 18 for the almost as long. The numbers don't really make sense, but never mind that. And if we go to HackerOne, which is another one, we see that the most common ones are still the same things. Like we have cross-site scripting on top, we have improper authentication, we have cross-site request forgery, which was now removed from the OWASP Top 10, and we have a lot of different things. Like we have all the injection attacks down here. So obviously we have we see the same things kind of as OWASP Top 10, but there are still a lot of things that are happening that we don't necessarily see in these statistics. So let's start with XML, because XML is fun, or something like that. So we have this simple application here. I can send it an XML, and of course I get the XML back. Nothing really spectacular about that. And I can, of course, get some XML. So the top window here is the stuff that I'm sending, and the lower window is the stuff that I'm getting back. So I can get something back, something that I've sent. So how many of you are familiar what an XML External Entity attack is? Not so many. Okay, good. So what we're doing with an XML entity attack is that we are defining new entities. So in this case, we are defining an entity here. And we're saying that this entity will be the contents of this file. And then we're using this entity down here. So let's try to send this one. And now suddenly the contents of the file appears down here. There are some caveats though, because the file needs to, or the collective file needs to be valid XML. But there are some ways around it. But this is kind of the basic example of XML external entities. We can steal files off the system. But But what if we move a bit further? So in this case, the application will allow me to post an XSLT, and it will take an already existing contact, which was the contact number 1, and it would create HTML by applying this XSLT to the XML. And I mean, the normal example would be I get something like this back, like I'm creating an HTML body table and then some table elements, and everything looks like this down here. Everything is fine. But XSLT has some functions. So first, we can start by kind of grabbing information about what's running on the server. So you can see we're using system property, and then XSL version, XSL vendor, blah, 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 all the way down here. And I'm getting back what product is actually running on this server. So now I can see that I have version 2 of XSLT, which is incidentally a very nice attack surface. But the first thing here is a standard XSLT1 feature, which is called document. And the document function is used here. So I'm going to just grab another XML document off the server and include it in the output. So now I'm stealing like the POM file, the deployment descriptor or the build descriptor of this system that's on that's running this vulnerable website. So I'm just stealing stuff, and I can figure out what kind of libraries is being used there. Are some of them maybe vulnerable, etc. So that's nice from an attacker perspective. I could also do XSE in the XSLT, because a lot of people now they kind of protect the XML parsers from XXE. But in this case, I'm doing it in the style sheet instead of doing it in the actual XML that I sent in earlier. So in this case, we're going to see the exact same thing happening. I'm grabbing the content of the file and just pushing it down here. But also, XSLT2 has a different function, which is the nicest one of all. It's called unparsed text. And it does exactly that. It reads unparsed text. It doesn't try to parse it. Just grabs the contents of a local file and pushes it into the resulting document. So if we send this one, we get the same thing. So now we've kind of stolen some stuff here. Maybe we could go even further. We could use this to connect to other systems. So in this case, I'm going to go and do a backend request to some system that's not available from the outside. So now inside one server, I'm going to try to pivot and try to access something else. And those of you familiar with, or actually the name of the system is here. So you see this is an Elasticsearch instance that I can reach by doing this. So this Elasticsearch instance wasn't available from the outside, but now I can attack it because I'm attacking it through another system. Also, there is something called blind XXE. And we can use this to steal files where we can't immediately see the result ourselves. Like in the examples I just showed you, you could see the XML coming back. You could see the contents. So what this thing does is it creates an entity that contains the contents of this file, and then it loads a DTD from this location. And this DTD looks like this. So it takes this data3 here, which contains the contents of this file now, and it pushes it to the end of a URL. And this one becomes a new entity that's pushed in here, and it's kind of back and forth a bit. But this allows me to kind of send off an XML, and somewhere back in the system somehow, I don't know where, this is going to be parsed, and it's going to read this thing, and then it's going to publish the contents of that file back out to my server. So I'm kind of stealing in a blind fashion. I don't have to see the result. I just have to be able to submit an XML and see if something happens later. It can happen immediately. It can happen a lot later, depending on the structure of the application. So an example from a bug bounty. This is from HackerOne, and I find this exact one to be a bit interesting, because if we look at the severity here, they say medium 5.3. So this is a medium severity. But they did pay quite a lot of money for it, $10,000. That's quite an amount of money. This was on a Twitter endpoint. All right, so this was XML External Entities. So off to the next one, and this one was also included in the OWASP Top 10 2017. Serialization is something we often use, like we communicate between different servers, and we have to find some way of converting our internal objects to some wire structure and then convert it back to internal objects. So it could be something as simple as XML. It could also be binary protocols. So we see a lot of like Hazelcast and all these kinds of caches. They use binary formats instead. But it could be JSON. It could be XML as well. This is used in a lot of different places. Like I mean, web services are an example of this. REST APIs are an example of this. But also all kinds of distributed caches, distributed databases, etc., etc. And there are a lot of places where we actually deserialize things, like in cookies, like in JVT and things like that. We also deserialize things. We've serialized it to something we can transfer, and then we get it back. The thing with deserialization attack is that we can use this to do a lot of bad stuff. We can do denial of service, like take down the system. We can manipulate the state internally. We can compromise the integrity, or we can even get remote code execution, which is the most fun one. So to be able to attack something, we need to have a gadget. So on the top here, we have a simple class that does nothing really. I mean, if you deserialize into this class, you're just going to get a person object with a name. The thing about the lower one, though, is that it actually does something. So if you can deserialize something to this object, it's going to do something in the constructor, which you might say, well, that's bad practice. Why are you doing this? But it happens that we can actually combine lots of gadgets that together form a chain where we can do something like this. This is a very simplified example. But if I were to actually write something and send it something like this, either JSON or XML, and it would be deserialized into that class, it would actually execute it. And this is quite bad. So, but there are some prerequisites. We need to be able to tell the system which object it's supposed to deserialize to. So luckily for us, or maybe not, some deserializers, they allow us to specify types. So here is an example from a .NET application. And in this case, you can see the $type thing. That's several places here. That's a feature, luckily, you have to turn it on for it to work. But in this case, it allows us to tell the deserializer which object it's supposed to deserialize to. So in this case, we're kind of combining a couple of gadgets. So we have the object data provider. It's going to instantiate a process, and it's going to give it the calculator as an argument, and then it's going to invoke the start method. So in this case, we build the process, and then we invoke start. So we have a couple of gadgets that work together here. Here's another example from a job application. And in this case, we actually have a vulnerable application that we can play with. So I'm gonna send this in. What it does here is it builds a proxy of a contact, and a contact is what we're sending back and forth. And then it uses an event handler and a process builder, and it basically will execute ping 3 times against this IP. The problem is I get this back. Like it says, well, I can't convert a Unix process to a string. Okay, so this didn't help me much. Maybe if I can get it to do something that I could actually see the end result of. And luckily for us, we can. So what I'm going to do in this case is that I'm going to invoke bash. I'm going to tell it to create a reverse shell back to my laptop. But then I first have to listen on the port. So I'm going to set up my laptop to listen on this port. And hopefully, I get a shell. So now I'm logged in to this server, and I can invoke commands. And incidentally, I'm also logged in as root, because of course they were running this application as root, which is not very nice. They shouldn't. So now you can see why this can be a really, really dangerous attack. So once again, here's something from HackerOne. In this case, Starbucks was the one that had the program. And of course, the severity here was critical. And they say, well, I could basically run code on your server. So that's not a good place to be in. The next thing we're going to talk about is something called server-side request forgery. And it sounds a bit like a CSRF, client-side request forgery, but this time it happens on the server. So it could be something very simple, something like this. So let's say we have a browser, we can send it a request to our server, and that somehow makes the server make some kind of backend request. It could be like a reverse proxy, but it could also be like, let's say we're uploading an image, but instead of uploading the image, we're just going to tell it, this is the URL where you can find the image, and then the server application goes out and grabs that image and pulls it back in and then uses it for our profile picture or whatever. So we can somehow influence the way that the server application will make HTTP requests out the back there. So a simple example, let's say we have a request coming in from the browser that looks like this, but we don't want to host the pictures on our server itself because we have this other host that are actually processing the images and creating all kinds of versions of them. So we have this nice little piece of code here that takes the incoming URL and replaces the first part with the URL of the actual place we want to go. So we kind of end up removing the first part and then building a new URL, and then we go out. And of course there are ways to attack this thing because it's doing something really stupid here. So the first attack is this. Well, if we just do .evil.com, it's going to remove the first part and then concatenate the stuff, and then we end up with going to images.example.org.evil.com, which is of course a completely different server than example.org. We could also do something like this. So we do a colon and then some variable and then at and then an IP. Well, what happens then is that the first part becomes like images.example.org becomes the username, and dummy becomes the password, and then the actual IP we're connecting to is 10.0.0.1. But these are kind of abusing a piece of code that's there, but sometimes we don't have to do that. Often we see things like this. Well, if you want to import data, just give us the URL and we're going to go out and grab something, like the image example, for instance. So in this case, maybe we could tell it like, go out and grab this XML data stuff and just bring that back in. Of course, we can then start pointing this at other services internally. So we could point it at, in this case, a MongoDB. We could point it to anything that runs internally, and we can access internal services. Because of the way URL handlers work, sometimes we can also grab files. Because, well, that's a valid URL, like file dot blah, blah, blah. So they're going to go out and grab that file instead and then bring us that back. But if we move to cloud services, it gets even worse. Because on many of these services, there's something called the metadata host, which is on that IP there. And on that, we can find lots of information about the server itself. And we can also get security credentials. And of course, we could use this to grab stuff off of MongoDB or RavenDB or any other things that has a web interface that we can reach from the system that we're attacking. So, okay, let's try to protect against this. We're going to do blacklisting. So obviously, we're going to blacklist that URL because that's a bad one. What about this one? Some of you might wonder, well, is that really a valid IP? I mean, the numbers are higher than 256. Well, a lot of URL parsing libraries, they do mod 256. So this is actually an IP with an overflow. This is a numeric version of an IP address. And this is a numeric version of an IP address with overflow. This is a hex version of an IP address, hex without the dots, hex with overflow, octal IP address, and octal with overflow. By the way, I stole all of this from a really skilled guy, Nicolas Gregoire. I have a link to his PDF down there. He's done a lot of interesting stuff in this space. There's a really good talk from him that you should look up, where he's talking about how he's used this to attack Yahoo and all kinds of big companies, which is really interesting. He has some really cool ways of doing things. But we're not quite done with the blacklisting stuff yet, because we could add a DNS entry to our own DNS and just point it to localhost. And something like this exists already. There's something called zip.io. So if we do 127.0.0.1.zip.io, that's going to resolve to 127.0.0.1. You could also do like a little bit more obfuscated stuff like this. Again, it resolves to 127.0.0.1, and this is like a base 36 of the number, the IP address, and you can see it's kind of in reverse order. Or we could do something like this. So www.bank.no and then this address, and it will still resolve to the same thing. For localhost, we could also do just .0.0.0.0 because, well, that's all the interfaces on the host. Or we could do something like this because it doesn't have to be 001. That's just what we're normally using. And of course, with IPv6, we get all kinds of weird things going on as well. So again, if we move to HackerOne, we see one here from Alien Vault. And this was, if you see what was happening all the way down here, you can see this is the IP that I was talking about, 169.254.169.254. And in this case, they use this host name here, metadata.nicob.net, which is Nicolas Gregoire's own DNS. This is a kind of a nice way of circumventing it. It doesn't look like it's going to be resolved to something. Of course, to protect against this, we have to always normalize the IP and resolve the IP and then look at the IP address to figure out whether we're connecting to something we're supposed to connect to or not. All right. So this was server-side request forgery. The next thing is template injection. And this was kind of added to the OWASP top 10 just as a single line to the injection, the A1. But very few people actually know what this is. And it can be quite dangerous. So a template could be something as easy as this. So we have a couple of HTML tags, and we have these mustaches or curly braces, and then a variable name. So what some of these templating systems are going to do is something like this. Like there are JavaScript things that does this exact thing. So they grab the stuff in the middle, and they do an eval on that to figure out what's the value of this thing. So you might have JavaScript there, and that might be perfectly okay unless someone else can influence your template. But it's gonna try to figure out what's the value of the stuff that's going on in the middle there, and then put it all together, and then there you go. So okay, let's do another example. So in this case, we have title, and then the title variable contains hello, and so the end result is an H1 with hello. Very basic stuff. But then we're going to build a bit more complex stuff. So we're using, and there are, let's imagine that the dots here are lots of lines of code in between, so we can't really see what's going on here. But we have two templates in this case, and the unfortunate thing that we're doing here is we take one of those templates and include the result of rendering that template in another template. Because now we allow whatever was in the title variable to influence the template. So a standard example would be something like, let's say the variables contained title was hello and body was world. So in this case, the first one would be h1 hello, and then we include that in the second one, and nothing bad happens. But what if title was included curly braces? So we would go in, and what we would get from the first rendition was h1, and then we would actually get new curly braces. So we would try to create a new template, an influence template, and then we would put that in the second template, and now things start to go bad. So once again, I like demos, so I'm going to do a demo of this. In this case, we have a simple server-side application that's vulnerable to this. So in this case, I've put my name up here, and if I click send, it's gonna send that in. And in this case, I've changed what the windows mean. So the top window now means the rendered HTML, and the lower window is the source code of that HTML. So you can see I put my name in there. It ended up inside an H1 and a P for some reason, and then it says hello. So that's what we're actually seeing in the browser. So what happens if I change my name then to 2 times 3, like that? Now you can see it says hello 6 already down here. So I'm getting it's actually executed what I wrote here, and the end result up here is hello 6. Well, that's kind of boring. Like, yeah, I can do math, but I can do that with a calculator as well. So let's do something more fun. Okay, so we're going to try, instead of using 2 times 2, we're going to reference an object that might exist. See what happens. Okay, now we're getting somewhere. I get a fatal error, and it says something about I can't I can't convert this class to a string, and things are bad, and I don't like this. But now we know that we have template injection, and we know we can access internal objects. But that's not fun either. Let's do something more. So in this case, we're gonna do an attack on something called twig. So what I'm doing here is I'm registering a filter callback called exec, which executes stuff. And then I'm gonna get that filter, and I'm gonna send it ID. So in this case, it tells me, well, okay, this system is running as www data with these groups and IDs. But I'm not done yet, because I wanna properly attack this thing. So instead of this, we're gonna go back to the bash thing. Same thing that we did for the deserialization attack. So again, we bring up our trusted console. Oh, we're still logged into the other server, so we had to get out of that one, set up a new listener, and hopefully, yes, now we're once again back inside another server. This time we're not logged in as root. As you can see, it says www data, and we knew that from the previous slide, but at least now I have a shell on the server, so I could try to do prevesc from there or something like that. Nasty stuff. So this was kind of server-side template injection, but it doesn't have to be server-side. So remember, it says 2 times 3, and then we got hello 6 back. What if I do it client-side? So now it returns 2 times 3 down here, but if we look at the result in HTML that's being rendered, it still says 6. All right, what's going on here? Well, the thing is now we're doing injection, but in a client-side templating framework. So in this case, you can see, some of you might have already, that we have Angular here. And I have ng-app declared here. So this thing runs inside, and this thing becomes a template. Hence, it tries to calculate this stuff. And now I'm thinking, well, I can attack this, because I can do alert 1, like classic XSS cross-site scripting example. But nothing happens, because what happens in a lot of these frameworks is they have some kind of sandbox. So both on the server-side templating frameworks, they have a sandbox sometimes, and also the client-side frameworks sometimes have a sandbox. And AngularJS in this version, they did have a sandbox, which was later removed, but at least they did. So this didn't work, but of course there are ways to break out of a sandbox. In this case, a bit of a weird example, but you can see it pops up an alert box there, and it pops up twice for some reason. So what I'm doing in this case is I'm, instead of invoking alert 1, I'm gonna grab a string, and I'm gonna grab the constructor of the string, which is the string constructor, and I'm gonna grab the constructor of the string constructor, which is the function. And then I'm gonna create a new function with alert 1 inside, and then the end of it, I'm going to invoke this function. So I'm circumventing the sandbox. This is a common exploit against old versions of Angular. What's interesting here that you can see is it did do some HTML escaping down here. But that didn't stop the thing from working, because this HTML escaping would have stopped a regular cross-site scripting, but it doesn't stop it because of the templating framework. It's going to see it as de-encoded, and then it's going to do its thing. So this works regardless. The next thing is insecure CORS. And this is something we've seen a lot of lately. And much of it is due to a guy called James Kettle, who works at Portswigger. He did a really good presentation about this at the OWASP AppSec EU last year. So we have this header, access control allow origin. What does it actually do? And to figure out what it did, I asked Google Translate for help. So, access control allow origin, example.com, access control allow credentials true. Well, if I translate this from HTTP to English, it says if the user is logged in and visits example.com, please allow that site to access the user's data. All right, this isn't actually Google Translate, of course. But it would be nice if it could do that. The next thing is we do access control allow origin star and then allow credentials true. which translated means if the user is logged in, please allow any site anywhere on the internet to access the user's data. This is, of course, not something we want. And this is not allowed. So if we try to do this, the browsers will complain and say, well, you can't have star and true. That doesn't work. So please do not do this thing. The problem is that people find ways of reintroducing this stuff. So the first one is the echo, where people will they will grab the origin header from the incoming request, and then they will put that as the access control allow origin, and then do access control allow credentials true, which basically means the same as star, because whatever comes in, you echo it back, and then you reintroduce the problem. A second version could be poor validation. So let's say we have some code that looks like this. So we grab the origin, and if it ends with example.com, we're gonna allow it, which means we allow not example.com, of course, because we didn't have a dot in there. And there are all kinds of versions of this where you have poor regex, where dot actually means any character. It can be all kinds of stuff. And this is a real example, by the way. I'm going to show you the write-up of it afterwards. And the last one is kind of odd. It's null. Access control allow origin null. Access control allow credentials true. What does that even mean? What does null mean? Let's ask Google Translate once again. If the user is logged in, please allow any site the user visits to access the user's data, as long as the site knows how to iframe with the sandbox attribute. That's the gist of it. So this is from James Kettle. If we do something like this, we create an iframe with a sandbox, allow scripts, allow form, and then we do the entire HTML document inside of it that's going to be in the iframe, and in there we do the actual XHR or fetch requests. We see origin null. That's what we're sending. So we're now in the null origin. And the null origin was actually intended to mean a distinct origin in every case, but in this case it means it could mean any site that exists anywhere, which is pretty bad, because that means that if we do a misconfiguration of some kind and we end up accidentally doing this, maybe it wasn't null. Maybe it was we had a variable there, but that variable was for some reason not set. So in Java, for instance, a string has the value null if we haven't set it, so it would be null, and then that would be what would be reflected back. So there are ways of where this can go wrong, even though we're not intentionally doing null. So I mentioned James Kettle quite a few times right now, and this is one of his write-ups for HackerOne, in this case for Zomato, and you can see the stuff in blue there. It would allow any domain ending in zomato.com, including not zomato.com. So this is kind of exactly the example I just showed. So that's not so good. So access control allow origin or course, that's a mechanism for us to relax the same origin policy, and we need to be careful with what we're doing with it and not just blindly or accidentally allow stuff that we're not supposed to allow. The last one is something called subdomain takeover. This is a pretty bad thing, and it can happen in many different ways. But there was a really good write-up of this from a Swedish guy called Frans Rosén at Detectify, and this is something that it's new, and I don't think we can say, well, we could probably claim that this is in the OWASP top 10 under security misconfiguration or something, but this is one of the really new attacks that have started appearing in bug bounties that I don't think we've seen much before. If we go back to XXE, that's actually quite an old bug. The first versions of XXE was back in 2002. There's been one in a Norwegian guy called Sverre Huseby. He found an XXE in Acrobat Reader in 2005. So that's a really old bug that kind of disappeared for a while and then came back. But I think this is a rather new one because it's kind of related to how we're using cloud services. So let's say we're using a platform as a service vendor, for instance, Heroku. So we can define an application running on Heroku, and we can customize the first part of this. So we can put our own name there, and by doing that, we can now have a kind of a custom domain name, but that's not good enough for us. We want to have our own domain, but at least we could do something like this. Same thing goes, for instance, for infrastructure as a service type of cloud services. So for S3 buckets, we often can have our own name as a part of the S3 bucket name. Also for EC3, you have some IPs and stuff in there. So, but I mean, we have some name, but we don't like these names because we want to have our own names. So here are some of the stuff that Detectify discovered. They've discovered over 100 services that are kind of vulnerable to this thing, including Heroku AVS, GitHub, etc., etc., etc. I think this has also been used against typical mail systems where you can send out a lot of emails to your clients. So let's try to explain what's going on here. So let's say we create an application at Heroku, and we call it ndc.herokuapp.com. And then we go into our DNS, and we wanted to have the actual domain name of ndcexample.com because we don't like the herokuapp.com stuff. We want to use our own domain. That's our brand. So what we do is we go to the DNS settings, and then we create a CNAME, a canonical name. So we're going to point ndcexample.com to this ndcexample.com.herokudns.com thing. So we're actually, instead of putting an IP there, we're going to say, well, if you're going to try to resolve this domain name, you're going to go to that domain name instead and ask that, because they know this stuff. So just an example, let's say we do an NS lookup on ndcexample.com, and we go to the registrar that's being used, and what we get back is ndcexample.com, canonical name, and then ndcexample.com.herokudns.com. So we can see that, okay, this one points to that one, same thing. This is an actual DNS query. So our browser, if we try to visit this site, it's gonna look up first. It's not actually going to do it this way because it's gonna ask a DNS server, and that DNS server is gonna do all the lookups, but let's pretend that this is what happens, because it kind of is. So it goes to let's say ndc.hackable.network, and it's going to DNS1.hackable.network because that's a DNS server, and it's going to come back with, well, you should actually go here instead. Okay, so we go to this DNS server instead, and we ask, well, can you give me the IP? And then we get back an actual IP. And then we go and visit our beautiful application that's running on Heroku. So these two lower servers are actually owned by Heroku, and the top one is our DNS server. Now, have any of you ever deployed something on a cloud service and then forgotten about it? Do you think any company in the world has ever forgotten about one of their systems running there? Well, forgetting about it, or forgetting about one of these systems is not the worst thing that can happen. It could actually be that we kind of forget about the system, or we remove the system because, well, we don't really need this system anymore, so we're going to go and grab it and just throw it in the bin. But we forget to update the DNS. So we remove the application. Let's say we go into Heroku and then just delete this. I don't need this anymore. But then we forget the DNS setting. So now the attacker, he can go back in and he can recreate the exact same service, the exact same name that we had. And the attacker now controls our subdomain. You get that? That's pretty bad. Like they now own a server that has our domain name on it. So what can they do with that? Well, they could do phishing with a proper domain, because they now actually have some code running on a server that has our domain name on it. So if they send out a phishing email saying, hey, please log into our site, go to this URL, and you look at the URL, and well, it looks like it's legit. So you go there, you enter your credentials, and bam, they're stolen. You could steal or inject domain-wide cookies, so you could do session fixation, you could steal sessions, you could do all kinds of stuff. You could do things like, let's say you have a self-XSS, which means a cross-site scripting that you could only abuse this cross-site scripting if you inject it into the server, because you can kind of put a value in a cookie, but then and then it would be reflected and it would be a cross-site scripting. But because an attacker can't fool someone else into injecting that cookie, then you're home free. But in this case, of course, if you own a subdomain, all you could do on that subdomain, you could inject such a cookie, and then you could change the self-XSS to being an actual XSS, which is pretty bad. Of course, you could put all kinds of bad stuff on there, like defacement. You could do political messages, adult material, you name it, malware, all kinds of bad stuff that might hurt the company if it was associated with it. Or you could go ahead and create an HTTPS certificate. So, demos. Yes, I love demos. Sorry? Sorry, the course? Yeah, probably. So the question was if we could abuse force for this, and I guess we can. So let's see. I have this service, and I'm hoping the internet will be my friend again, because it was a bit. See here. Yes. So there is. I'm gonna try to stay still. There is an application running on this domain here. So what if I go to this domain? I do this. Nothing there. Okay, bring up my trusted console. Oh, I'm still logged into the other server. So let's clear this. We could do like, I don't think I have it here. If we do an NS lookup for NDC Security Day 1, we see we get a lot of stuff back. But this one didn't resolve. Let's try. Nothing happens. Nothing happens. Okay, maybe I lost my internet again. Sorry about that. Let's see. The thing is that this host name is now open for attacks. So anyone could go in and register a system that would actually have that host name. They just have to put up a system there, and then they could take over my domain. And lo and behold, someone just did. Oh, it suddenly resolves. Okay, what happened? Oh, someone owned my system. Damn it! And the owner sits there, by the way. So he now went to the system because, well, all he had to do was go to, oh, lovely marquee. All he had to do was and deploy a app with the exact same name or the exact same custom domain name, and now he owns my site. Okay, that's not so nice. So it's really easy and it's really fast, as you could see. He was sitting there right now, and he just took over my my subdomain here. So this is an example of this once again from HackerOne. This is a Swedish guy, Mattias Karlsson. He did a subdomain takeover for Shopify, which paid him $500. And in this case, it was an S3 bucket. So you can see the details down here. He could basically grab one of those buckets from them because they had a DNS entry that pointed to them, but they no longer used them. So, and this is an example one, an interesting example. Like you have this thing, which is the certificate transparency log, and where all certificates that are ever created by a legit CA, they will have to publish a log of what they're doing. And if you look at the center of the screen here, it says, Szymon Grzeski has hacked prod2.uber.com as an SSL certificate. And I think this is because he was able to grab one of Uber's subdomains, and then he obviously used some kind of CA here, start.com, and was able to then get a certificate issued for this server. And of course, when he owned this thing, he could add all kinds of stuff to it. And then he got some certificates. I'm not sure if Uber was so happy about him doing it, but anyway, that's the way it goes. Some resources here. The first one is Disclosed H1. This is a Twitter account that you really should follow because they publish all these HackerOne reports that I just showed you. This is a bot that just publishes every time a new public report is made available. You can go and read them, and not all of them have a very interesting amount of details because a lot of them are heavily redacted, but there is a lot of stuff there, and there is a lot of good stuff to learn. These two next links, why so serial? Those are for serialization attacks, so those are tools for kind of attacking, they have gadgets in them, the gadgets for attacking different kind of deserialization frameworks. The XXLT for practical attacks, that's where you can find all these functions like document and unparsed text, etc. Template injection, RCE for the modern web app. You can see once again, if you look at the end of the URL there, or at the first line, it says Kettle. So this is also James Kettle, which is basically also a guy you should follow. His Twitter handle is Albino Wax. And he's one of the guys who works with Portswigger, which creates Birdswit, which is a common pen testing tool. Then you have Detectify's original blog post. As you can see, it's not that new. It's from 2014. But we've seen a lot of this happening in the bug bounty space lately. And then you have Nicolas Gregoire's server-side browsing considered harmful, which is about server-side requests. And then the course talk from James Kettle all the way to the bottom. And that's basically it. Any questions? No? Everything is clear? So are you scared? Do you have to go back and patch your stuff now? No. All right. If there are no questions, I think we can end it there. So thanks a lot for coming.